This is a problem that explores your knowledge on paramagnetic properties of elements and ions. The problem is, which of these ions in the ground state are paramagnetic? Titanium 2+, zinc 2+, calcium 2+, or tin 2+. Take a few minutes to think about this problem, lay out a solution plan, work on the problem, and once you have obtained a solution, compare that with the one that will be described shortly. The plan to solve this problem will consist of, number one, write the electronic configuration of the element, that is without being an ion or in ionic form. Number two, determine the electronic configuration of the cations that will form when electrons are removed to form the cation. And number three, determine which ions have unpaired electrons. As we recall, those ions that have unpaired electrons are considered to be paramagnetic. Okay, so the plan to solve this problem starts by writing the electronic configuration of each of the respective elements. So we are going to write the electronic configuration of the titanium. Start with that one of argon, and then if we look at where it is in the periodic table, we can quickly determine that that corresponds to the fourth period, 4s2, and also has 2 electrons in the 3d orbital. For zinc, we also start with the electronic configuration for argon, and if we look at the position of this element in the periodic table, we know that it's in the transition elements region, and we also have a 4s2, and it's the last one in the transition elements region, so we're going to have a completely filled the 3d orbital. For calcium, we started with the electronic configuration of argon, and we know that it's on the fourth period, and the electronic configuration is 4s2, argon 4s2. And for tin, we look at the periodic table and we realize there is one period below, so we are going to be using the electronic configuration of krypton. And this is far into the right side of the periodic table. We have to add a few extra electrons, 5s2, for the 10, indicating that it's past the transition element part, and add 2 in the 5p2 orbital. Okay, the second part of this is determining the electron configuration of the cations. Cations, for all of this, means that they are going to be losing, if M is the metal, that we're going to be losing 2 electrons in each of them. So the question is, where do we remove electrons from? And as we discussed in this chapter, we are going to be removing electrons first from the 4s2 orbitals. So these are the ones orbitals that will be losing electrons to form the cations. So the electron configuration for the corresponding metal ion for titanium is going to be that of argon, 3d2. For zinc, we want to have that of argon and 3d10. For calcium, that electronic configuration of argon, and for tin, the electronic configuration of krypton, and we are going to be losing, in this particular situation, the electrons in the 5p orbital. So we have 5s2, 4d10. This is important to note because this is not one of the 4s orbitals or 5s orbitals. This one is easier to remove because it's higher in energy in the structure of this particular atom. So what we need to consider next to determine if it is paramagnetic or not is to determine if there are unpaired electrons. We know that the orbitals, we have normally 5 d orbitals. So if we are going to represent the orbitals as such, and just taking the first case as an example, the titanium, the 3d2, we know that the first electron will be localized right here. The second electron will localize in this other orbital. So this particular component is going to be, or this particular ion is going to be paramagnetic because it has 2 unpaired electrons. So I'm going to put a P in front of titanium to indicate that its ion is M2 plus ion is paramagnetic. The second case is for zinc. The zinc ion has an electronic configuration of 3d10. We're going to have to add 10 electrons. Let's continue with the take advantage of the orbitals I already drew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we can see here, all the electrons are paired. That means that zinc is not paramagnetic, it's diamagnetic. The third case is for calcium. Calcium has the electron configuration of argon. That immediately tells us that everything is paired, so that would be also diamagnetic. And lastly, we have tin. And tin, if we look at the electronic configuration of the corresponding 2 plus ion, we can see that everything is paired as well. So this one will be also diamagnetic.